Today we are talking about RabbitMQ 3.13, a version that is coming soon, probably within a couple of weeks. So November 2023. We have a few team members here. And we'll be talking about all the new features, all the major new features, including Khepri, our amnesia replacement, and Classic Q's version 2 now, the default. Some message store improvements, MQTT5, stream filtering, and message containers. That's a lot of stuff coming in 3.13. So let's start. Jean-Sebastian, let's talk about Khepri. What is it?
Hello, everyone. So Khepri is the database implementation that we worked on for quite some time now in the RabbitMQ team. The goal is to replace the one we are using currently, which is Mnesia, which is provided with Erlang itself. Let's start with where and why do we need a database inside RabbitMQ. We use currently Mnesia as the database to store everything except the message bodies and index. So it means that all internal users, all virtual hosts, all policies, runtime parameters, bindings, the arguments of the queues and so on, everything is recorded inside this Mnesia database. However, message bodies and the order of messages in queues, this is stored outside of the database. It has its own message store for that. The biggest benefits of Mnesia is that it is provided by Erlang itself. So you install Erlang and you can already use that database. It also supports replication, so that it means that when you cluster several nodes of RabbitMQ, what we do really behind that is that we ask Mnesia to form a cluster with every RabbitMQ nodes. And out of the box, everything we store in Mnesia is replicated and available on all RabbitMQ nodes. So this is managed by Mnesia itself, not RabbitMQ. One aspect of that is that you can modify, there is no master-slave notion in Mnesia. Every node can accept modifications from RabbitMQ, and every modification will be replicated to all nodes. And this is really comfortable for us as developers. This is less comfortable for end users because when there is a network issue, like we lose the connection between one node and the rest of the cluster, then that node can still continue to write modifications to that database. The rest of the cluster will continue to, and it is a problem when the connection comes back and the cluster, all nodes in the cluster see each other again. Then we will have to resolve conflicts. We have different strategies provided with RabbitMQ. The default one is to ignore conflict, but we have other strategies. One is pose in minority. So this is where we will ask that single node, which is isolated from the rest of the cluster, we will ask it to stop, basically. And we also have another strategy, which is auto heal, that also tries to resolve the conflicts we may have with the data stored in in the database. But over the years, we saw through user reports that this is not robust. And that's why we started to work following some work from Carl a few years ago to work on a database based on the Raft implementation that Carl wrote for the quorum queues. So the idea is to use the same technology as what we have for quorum queues and which is proven now, and use that technology to build a replicated database that we call Khepri. And we will introduce that database in RabbitMQ 3.13 as an experimental feature. So starting with 3.13, if you enable the associated feature flag, everything except message bodies will be stored in Khepri. And that means that because of the nature of Raft, we won't have to resolve any conflict like quorum queues. It means that when a node is isolated and does not see the rest of the cluster, it will simply refuse to make any changes to the database. And this way, it will wait for the cluster to be healthy again, and it will catch up with other nodes of the cluster and resume actual work. So the benefit, as I said, is that there will be no conflict to resolve, and the content of the database will always be consistent. The downside is that node may not work as you expect, because without right access to the database, it may not be able to serve clients connected to it. So everything which those changes in behavior, we try to document that in the pull request on GitHub, where we introduced that new feature. And we still need to update the documentation to reflect that, so that it's clear to everyone how RabbitMQ will behave once Khepri is enabled. What can I say? I think that I covered pretty much what Khepri will do. And yeah, I think many people will say that in our team, we really need a lot of help from the users to test those new features and see how RabbitMQ behave in your different workloads.
Certainly. A good thing is there are at least two very common issues where people report amnesia is overloaded, for example, and yeah, that will just go away because there will be no amnesia, of course. There's also often some questions about handling network partitions or forming a cluster. These are all topics that will fundamentally change, or just hopefully won't be a problem anymore. So that's great. That took, how long has it been since the Khepri project started?
I can't remember.
Over 2 years. Well, Khepri specifically took over 2 years, and Khepri and Ra collectively about 6.
Yeah, there were other experiments before Khepri that were abandoned and also took time.
I actually dug out the first time I sent you that link to the initial little prototype thing that I made, and that was 15th of March 2021.
Okay. 2 years and a half.
Yeah. Well, okay. Congratulations. That was a lot of work. Well, still quite a bit of work ahead of us.
Yes.
The release candidate for 3.13 is already available, and we already found at least a few issues there. But by all means, please download the release candidates and test that. Also, as a reminder, Khepri in 3.13 will be opt-in only, experimental. It will not get enabled on its own unless you explicitly do that. So, you can just use 3.13 with Nijia, but we would really appreciate in your test environments, in your home labs, enable Khepri and see how it goes. Overall, in terms of like using Rabbit, it should basically behave the same way. Like all your usual tools still work, all your usual CLI commands still work. If you import export definitions, that still works the same way. In many cases faster, which is nice. But yeah, in terms of how you use Rabbit with Khepri, there's no like obvious user visible differences, I think, or I can't think of.
There is one.
Really.
There is one. You must keep a majority of nodes online. If you lose a majority of nodes because it's a route-based system, just like quorum queues, just like streams, you must have a majority of nodes up. And right now, if you lose a majority, your quorum queues and streams won't be available. Starting with Khepri, everything will behave the same way. But so many data services these days use Raft. That I think that's generally an accepted trade-off, I think, in the industry.
Yeah, you'd hope so by now, and that's that's a way to go. I think one operator-facing change, I believe, is that the network partition strategies are null and void when you have Khepri enabled. Is that the correct JSP?
Yes. I don't remember if we correctly report that to the end users if a network partition is configured, a network partition strategy, handling strategy is configured.
But they don't do anything anymore if they think they've detected a network partition. There's no restarting of the Rabbit app or anything like that going on.
No, there will be ineffective in.
Just that should result in a much more stable system. I would have thought, just not doing that sort of relatively unhelpful stuff. And another thing that I don't know if you mentioned, but classic mirrored queues aren't usable with Khepri, right?
Yeah, that's correct. When you enable Khepri, you also how can I say? There are some features in RabbitMQ that you cannot use anymore. The first one is the one you mentioned, classic mirrored queues, which heavily depend on Mnesia. The second one is the concept of RAM nodes, where the database is in memory only and not on disk. This is the second feature which will go away with Khepri. So once Khepri is the default, the only database in RabbitMQ, yeah, all of them will write data on disk.
And those two features are deprecated anyway. So
yes, this is correctly reported to the end users in 3.13. So you should be warned if you are using those features that they will go away.
Yeah, good.
Awesome. Let's talk about some of the other features. So Classic Queues version 2 by default. Classic Queues version 2, or the storage backend version 2 for Classic Queues, was initially introduced in 3.10 and then significantly improved in 3.12. There are further changes, mostly around the message store in 3.13. So just to explain, basically in Classic Queues, we have two different ways of storing messages. Messages up to a certain limit, which is by default 4 kilobytes, are stored per queue. In Classic Queues version 1, it's called embedding in the index. In version 2, it's basically a per queue message store. And then messages above this threshold, so above 4 kilobytes by default, are stored in a shared per vhost message store. And the improvements to the message store are coming in 3.13. Classic queues storage backend version 2 becomes the default in 3.13. So hopefully the only thing you will notice is better performance. This version of the queues has been around for quite some time. We know there are quite a few large users at this point. So hopefully there is no bugs hidden there. Important to know is that you can move between version 2 and version 1, at least for the time being. I guess at some point we'll just remove version 1, but for the time being, you can just set the policy with the queue version equals either 1 or 2, and the queue will be migrated internally. So this particular queue won't handle any messages during that time, but unless the queue is very long or something weird is going on, this should be a pretty quick operation. If you want to try version 2, you can set this value to 2. If you find an issue, you could set it back to 1 and report the issue and keep using version 1 until it's fixed, for example. So it's relatively simple to move between these two versions. And yeah, that's pretty much it about Classic Queues version 2. Any questions? If not, MQTT5, we did not decide who's going to talk about that. We kind of, I guess, assumed that maybe David would be here, who worked on that. Who feels competent to talk about MQTT5?
I can. Well, it's just an extension of the rework of the MQTT plugin. That's it. It's not really a different protocol from 3.1. It's a revision. There are finally some sensible changes, like error communication from the server to the client has been improved, and MQTT clients will not cause connection storms, that kind of thing. So it feels more of a protocol designed for the real world and not some PhD fantasy. Definitely a nice round of improvements for MQTT. And yeah, enough clients and tools should support it now for you to benefit from it from day one. Quite often they will use MQTT5 internally and you wouldn't even know.
Yeah, and that's on top of all the changes from 3.12, where MQTT support was significantly improved and we can handle many more connections than we used to. So if you're an MQTT user, definitely use 3.12, and soon, hopefully, 3.14 will be even better. All right, Gar?
Yeah, just to mention, it's not available now, but David did a good talk on MQTT5 at the RabbitMQ Summit conference that's just passed. So at some point that will be published online, and that's well worth watching if you're if MQTT is part of your use case, because it's really RabbitMQ is really getting there with MQTT. I think it's really good now.
Stream filtering, I guess that's for Arnaud for start, and we see how it goes.
Yes, I can take it. Hi everyone. So stream filtering, it's a feature for when there are use cases where a stream consumer just wants to process a subset of messages in a stream. So a simple solution for this is to just get the whole stream and filter out in the application code. But it means that you get the whole content of the stream going on, on the network. So we came up with a solution to avoid transferring the whole content and have some first level of filtering on the broker side, and make it quite efficient and decoupled from the messages themselves. So the idea is to associate each message with a filter value. So it's some kind of tag, whatever you call it. We call it the filter value. So the publisher will publish a message, and it will associate the message with a filter value. So the filter value is just a string, and it can be anything. For example, a logical geographical location, like the country or the state. And then a consumer can ask for messages for a given filter value or a set of filter values. So it could be a consumer that wants only messages from France or the US, or France and the US. And then the worker will do its best to dispatch only those messages. The thing is, the way streams are made, we actually, for delivery, we dispatch a whole bunch of messages that we call a chunk. And inside a chunk, you can have messages that you don't want. For example, you want France messages, but you may have all messages from other countries dispatched to your consumer, because again, they come as a big chunk of messages. So it means that the client must do some client-side filtering as well, which matches the filter value that the consumer asked for. But thanks to this, we can save some bandwidth by not dispatching a chunk of messages that actually don't have any messages with the filter values we asked for. And the way it works, it's a Bloom filter that we actually add inside the chunks on the broker side in the storage. And the broker can ask to this filter value, which is optional actually, can ask to this Bloom filter, sorry, whether a chunk contains a value or not. So this way the broker does not know much about messages. You just have to work with this Bloom filter inside inside each chunk of messages. So it works pretty well, but the benefits really depend on the use case. So how many filter values you can have. So for example, if you have all the states of America, it's going to be 50 filter values. And it also depends on the way you this filter, the messages with a given filter value is scattered, spread across your stream. It will depend also on the ingress rate. So many factors. So people just have to test what's best for them. And it's also possible to have some configuration, especially with the filter size, so the Bloom filter size for each chunk. So a Bloom filter is probabilistic, so it can give false positive. So you can make it less, more accurate by increasing his size. But it means that your stream will be a bit larger because you're going to have the filter size pre-allocated for each chunk in your stream. So that's pretty much for the overview of the feature. We published a couple of blog posts already that describe the feature. There's even some code to test it, or even commands with our performance tool for streams. And it's already actually implemented in a few client libraries. So it's supported in the Stream Java client, in the Stream.NET client, and maybe in the Go client. And it's also supported in our Stream performance tools. If you want to experiment, you just have to use the snapshot or an RC of or beta of 3.13. So that's quite an exciting feature. But to be honest, we don't know how people will use it. So it we're expecting some feedback. I think that's it. Any questions? Anything I forgot?
That's pretty much it, I think. I mean, it's a the brief motivation is to reduce data transfer between server and client when you're not interested in all the messages. And as you said, it can work very well for that for specific workloads, but it does take a little bit of analysis and tweaking to get it optimal.
And the last topic for today is message containers.
Guess that's for me. So, okay. So historically, inside RabbitMQ, messages have been stored in the sort of the original primary protocol format, which is the AMQP 091 or before. So internally they've been stored in a format that we refer to as a basic message, and that's worked reasonably well. What's been happening with other protocols as they've been adding is that they have to squeeze themselves into this basic message format, and some of them are fit quite well. Like MQTT is not really a big problem. MQTT doesn't have a lot of metadata in terms of messages. A little bit more now for MQTT 5 with because they finally added user properties, but which are sort of application headers, whatever you like. Yeah, otherwise they don't fit so well. AMQP 1.0, when that came out, was implemented as a plugin in RabbitMQ, and yeah, that data model is more rich than more complex and has more metadata, more sections, more stuff, all of which, you know, well motivated, but still there's more of it, and it doesn't fit very well inside the AMQP 091 data model. So we had to sort of jump through some hoops in order to, you know, try to retain the original message as best as we can, but data fidelity suffers. So message containers is an approach to overcome how we store, to change how we store messages internally, and rather than converting at source when we receive them, we simply sort of put them in a little internal wrapper envelope, if you like, and we store that, and we store everything. Where the ultimate goal of message container is that we store all messages that we receive from any protocol that we support in its original format. So for 3.13, this means that AMQP 091 and MQTT will be stored in their original formats internally, and then we will be expanding that with STOMP and AMQP 1.0, and that's probably going to be a 4.0 feature. So we store them in this wrapper, and that's only half the story, really. The other part of it are the conversion rules. So previously, as I said, we convert when we receive the message. Now we only convert if we need to. So say you send a message from MQTT and you consume it with AMQP 091, we will do the conversion when you consume the message rather than when we receive the message. So it's converted at output, and that means that if you only use one protocols, you will never, once it's implemented for all protocols, you will never take the cost of doing message conversions, which is nice. So that's part of the rule. The other side of things, which I think is probably the more important and for the user at least, because, you know, as far as you can see now, this is not a user-facing feature. The other side of things is that we have now gone quite long way towards formalizing our conversions and, importantly, and this is what I'm working on right now, document them. So there will be a document with lots and lots of tables that describe field by field the conversions that RabbitMQ will take when it converts your data from a given protocol to another protocol. So that's really, the conversion rules are really the big thing about message containers, not the fact that we pop them into an envelope. So the container contains the original message along with the conversion, with the right rules to convert it into any protocol that you want to consume for. So that's pretty much it. So
are there any changes to these conversions? Can there be
change
in the application?
Edge cases here and there where we've changed some conversions that simply were wrong before. Arguably, none of the conversions before were formalized or even documented. So there will be some, and that will be included in the document as well. Where you may see it mostly is conversions to and from streams. So streams, we store them in AMQP 1.0 format inside. So they are still going to be converted on receipt. So when you, if you publish to a stream from another protocol, we do need to convert that into AMQP 1.0. Luckily, that's our richest data model, so everything almost fits, without any fidelity issues. But yeah, when you consume from a stream, you may notice that some fields, for example, X headers in your AMQP 0.1 headers section will be added to the message annotations rather than the application properties, because that's the correct way. X headers belong to the broker. They need to be things that the broker understands or emits. Any other headers that don't begin with an X belong to the application. But all the data will still be there. So that's how it will work. So yeah, that's.
I can mention a couple more things. Sorry, Carl.
Go ahead.
So one is with this, if we decide to do this, I don't want to make any promises, but this makes it very easy. For example, folding MQP 1.0 into the core for 4.0, so that it's not a plugin, it's always enabled. And in fact, it is arguably the core protocol, or at least as close as we can realistically get there, while supporting how many, 5 or 7 if you add WebSockets, so consider that a separate protocols. So yeah, it will be MQP 1.0 based, even though MQP 0.91, of course, cannot be removed realistically. There are just too many users. And another thing that I would like to mention is that if you publish and consume using the same protocol, which is probably the majority of users anyway, then nothing changes for you, except that, well, things maybe in some edge cases, things will be slightly more correct, but likely you will not notice any changes at all, because there will be no conversion, for example.
Exactly, and that's part of the goal, is to do as little conversion work as possible, because if we always store the data in the original format, we never lose any data on input or any fidelity of the data. So that's it's.
Do you expect any impact on the performances?
We haven't seen any so far. This is not primarily a performance oriented change. This is about data fidelity and conversion formalization. But yeah, Michal, you've done some testing. You couldn't see any notable regressions in terms of performance.
Nothing obvious. Yeah.
It may be that the internal packet is a few bytes larger, but when it goes onto disk, but wasn't enough to be notable.
Public service announcement. As a reminder, we are removing classic queue mirroring, and that will not be available in 4.0. And we already started working on the PR to actually remove classic queue mirroring. So if you are still using that, it's really time to start moving to quorum queues, or maybe streams, or maybe classic queues without actually mirroring are good for you. Just to clarify, there's that question keep coming up. We are not removing classic queues as such. In fact, you just heard that we invested a lot into classic queues version 2, which are much more performant, and they will be there. There are use cases where you need a lot of queues, for example, and classic and quorum queues are just realistically not the solution. Like for IoT use cases where you may need 1 million queues, that just won't work. Well, I'm not sure it would actually work with classic queues right now either, but we know there are people with hundreds of thousands of queues, and that works. And that will not work with quorum queues right now for sure. So there are use cases for that. Another use case are exclusive queues, and they are always classic queues, and they don't need mirroring. So there are still valid use cases for classic queues. They will remain, but if you do nothing and just upgrade to 4.0, you will keep using Rabbit, but you will no longer have any replication of the queue message of the messages in the queues. Or at least that's the behavior I assume. We don't actually have that PR finalized yet, so but I assume things will keep working. You will just upgrade, and it's as if you deleted the policy to mirror the queues. Everything keeps working, but without mirroring. That would be my guess.
Yeah, there will be some warnings maybe in the logs about some policies that are no longer effective. We will not error out on them or something or anything like that, but they will simply have no effect. There is a number of small things in 3.13. Feel free to take a look at the release notes. As we have been doing every year forever, we bump the minimum required Erlang version, and just like we did with 3.12, that required version is the latest release series available, which is Erlang 26. So yeah, I think everything else is just small assorted changes, and all the bigger items will come out in 4.0, sometimes built on top of what you see in 3.13. We cannot really rule out a 3.14, we will see. But once 3.13 ships, most of the effort, of course, most of the time invested will go into 4.0.
Yeah, one note about Erlang 26, the defaults for TLS settings changed in Erlang 26. And we've heard from a few users, at least, where they got caught by that. Basically, Erlang 26 enables peer verification by default. So if you don't explicitly set it to verify none in your configuration, you may end up in a situation where you upgrade Erlang to 26 and RabbitMQ can no longer make connections, for example, to your LDAP server or to your HTTP authentication server, or even between the nodes of RabbitMQ itself. So make sure that you test this change before rolling out in production. But I guess that's it for today. Thanks a lot, everyone. And
thank you, everyone.
Thank you.